Thank you for joining this session. I think this is second last, I think. There's one more session after this. Right. So I came in, I'm based out of India, Mumbai. So I flew in today morning. So please pardon if I'm like not sounding right, yeah? Okay, so this is Streamlining AI Pipelines with Elyra. Since today morning, how many of you attended, heard the word KServe? And VLLM? More actually. Right. That's nice. And how many of you know Elyra? So that's the whole point. Like I want to emphasize more on Elyra and how it helps a data scientist to actually create a pipeline from the data scientist point of view. So that, and they don't have to worry about how to create a pipeline basically. Just drop in the code and the workflow is created on its own, right? That's one of the important ideas about this presentation or session. Then I also want to run through a concept of how everything comes together, okay, with something like this. This is the diagram. I'll go back to the agenda again. But so I want to cover something like we have a data scientist, they run through and actually have something like a pipeline to create a workflow for anything like for data preparation, data pre-processing, model training, okay, model testing, experimentation, those kind of things. So that's once that is done, right, the model is pushed into a model registry. Okay, it can be any model registry. We are working on creating something in our own product set. It can be a simple S3 bucket for now, right? Okay. Once that is done, now that is the part of the developer, right, as a data scientist creating the models and pushing it into model registry. Architecturally, I want to create a separate isolation for deploying the model onto a platform, right? Let's say, for example, I want to deploy model onto OpenShift as a platform or a Kubernetes. I want to separate that as a CI/CD pipeline, basically. So when there is a model being checked into a repository, there's a pipeline which gets triggered automatically to actually do the whole deployment, modeling, model deployment, model management, monitoring, and those kind of things. So that's the CI/CD, which is using Tekton as the pipeline. So I'll try and, what I've done here is, in this presentation, I have created videos. Basically, I have created arcade videos. So they are like click to demo. When I go to a specific section, there is an arcade video demo. When you go to the presentation I have uploaded, you will see those demo videos, links to that. So when you go and click that, you can actually feel the whole demo yourself when you go back as well, right? So that's the whole purpose of creating that and giving it to you as a resource, so that you can actually go and do the demo on your own eventually and understand what was happening or what I was trying to do. Okay, and once the Tekton can actually do a deployment of the model using VLLM, for example, right? So that's the whole thing. Then we can have a set of monitoring set on that, okay, and depending on how the monitoring impacts the model-specific performance, like if the model is getting biased, it can either be in the Elyra where the data scientist does experimentation and figures out, okay, how the models are performing and then pushes the model, right? Eventually, over time, the model gets biased, okay, or the model is not good enough, right, at that point in time. So maybe that monitoring can help feedback to the data scientist so that the data scientist can actually go and create the model again or retrain it or do whatever they want to do, right? So that's the concept which I want to walk through with different product sets coming together. This is what I wanted to show and tell basically. Okay, accelerate AI pipeline deployment with Elyra. So I'll focus on Elyra part here. There's a KServe for scalable model deployment and VLLM for efficient LLM inference. These two topics are already covered in detail today. Okay, so I'll not go deeper into these two topics. Okay, we'll just try to understand the basic concepts on why those elements or components are available as part of the overall integration point here. And then I'll talk about some of the best practices in terms of why we should have this kind of a scenario. Of course, this is my opinion basically. This is how I would architect, okay, if I'm running an enterprise, right? So you can actually think how you want to run. You may completely have a different perspective to this whole CI/CD process, right? You may actually use something else, right? You may use Jenkins, for example, or you may not use that. In your environment, you don't need that, right? So this is purely an opinionated, my opinion, which I'm trying to explain here, and the concept which will also bring together different product sets which are all open source product sets, basically. Starting with Elyra, right? Okay, now the challenges are AI pipelines are too complex, right, to create. And a data scientist's job is not to go and actually create the pipelines, right? They are supposed to do their data scientist work, right? Okay, and make the models optimal, perform optimally, or do the data processing coding, right? So the data pre-processing, experimentation, deployment, these things are very complex. There are too many moving parts in there, right? So if a data scientist have to create a pipeline, it's very, very difficult, right? And there's a team of data scientists, they can actually collaborate using these kind of tool sets, right? So Elyra, it's a visual editor. Basically, it's part of the Jupyter notebook, okay? It's used to design pipelines with extra glue code. It converts your notebooks into automated workflow. I'll show you that, and it runs locally on Kubeflow. Locally, you can use Kubeflow. Anyone attended today morning? Abhinav from Kubecloud, actually. He did a session on Kubeflow. You should actually check that out. Nice session for you to get an understanding of Kubeflow. And then Rafael from IBM, I'm not sure if he's here. He actually did a session on KServe and VLLM. Okay, it was an introduction beginner session. Nice session, you should see that as well. And then if you come here, you can get to a better understanding of what I'm talking about, actually. Right, so this is sort of a visual editor. So if you see here, these are all the tasks, which are all my Python codes, basically. Okay. So if I want to, I can download the data set, do the preparation of the data set, right? Okay, then create the model, then train the model based on this data set, evaluate the model, upload my artifacts or model, and then basically delete the artifacts when the model is uploaded, or I can continue having the artifacts uploaded. So this is the pipeline, basically. Now imagine if someone has to create a pipeline like this, right? In Kubeflow, someone has to write a code to do that, right? Why someone has to write a code if you have Elyra, right, in place? That's the whole idea. So once you run this as a pipeline through Elyra, you actually get this whole DAG created for you. Okay. It's a graph which gets created once you run that pipeline. Now this is the demo link which I was talking about. This is Elyra, so I want to show an Elyra demo here, right? I have everything here. In case if someone wants to deep dive, I have all the tabs available. We can do a live discussion also on that. But just to save time and for you to go and access it later. So this is the pipeline I showed, right? So this is running on Jupyter Hub. Everyone will be aware of Jupyter Notebook, right? So this is a Jupyter Notebook, but we also have Elyra module installed in this, right? So that's the runtime running on Open Data Hub, which is our OpenShift AI product from Red Hat's perspective I'm talking. Right. So you see here, you have all these codes being created, pulled, okay, and when you submit this as a pipeline here, okay, just provide a few inputs here, like what is the model training, okay, then it provide where the model needs to be stored, right? So in this case, I am using MinIO, okay, but we can use any other storage for that matter, or a model registry, right? And this gets run, okay. And this is what an outcome looks like once the execution happens, okay. So this is a DAG you get from the model pipeline which I showed earlier. And this is all executed, and I'm just showing you the final outcome here, because the execution takes like, depending on the model, what you're training, it may take hours also, right? Okay. So this is one example I wanted to show in terms of right from data pre-processing to model deployment, model storage, not deployment. We are not yet deploying the model here, for example. Just make sure of that. Now once this is done, this is another example which I wanted to show. So there is, so this is an example of RAG. Okay. I hope everyone is aware of RAG, right? Retrieval augmented generation. So what I'm doing is I'm actually creating a pipeline as a data scientist, and I want to push all the new information, ingest the new information to my RAG, right? So how can I do that? I can just simply drop the codes in and connect to the Elyra connector, and it will go and just create a pipeline and get executed. Kubeflow is the backend engine which actually runs the whole pipeline. So Elyra converts this pipeline into KFP, Kubeflow pipeline basically. Okay, that's the advantage of Elyra. So these are the 4 tasks here. Now this is the simple, I had a test response here. I'm just testing the response of my data, which is being ingested in the RAG database. Now I want to, let's say, I want to also test the quality of the outcome, right, of the RAG database. I can simply drag the other code in here, connect through the input and the output tasks, and it's as simple as this, basically, and just submit this. This will go and create another DAG for me and run the pipeline. This is the code which is being used to actually ingest the pipeline. Right. Similarly, if I want to have a security task as well, before I move this into storage, I can just add another task into it. If they are all running parallel, these are all these 3 tasks will be run in parallel. Okay, after LangChain, PG vector, whatever is that task doing basically. And this is my UI on the right side. Okay, on the right side of yours, if you see, that is where we define all the parameters. So if it needs an input specific setting or an output to be provided or an input to be taken from a task, those are the values being defined there, okay, in the UI itself. So the data scientist doesn't have to worry about actually creating the code, Kubeflow code to go and get executed. Okay, it's a simple drag and drop basically. We can also check the data science pipeline. So if you see this is where a data science pipeline is getting executed. Okay, these are all the parameters where it is actually getting the model from, for example, to be deployed, right? Okay, so those things are all defined here, or where it wants to store the model. And basically this pipeline will be the endpoint which will be used for Elyra to go and create and execute the pipeline. Right. So this was about Elyra. The next is, there are 2 talking points here, KServe for scalable model deployment and VLLM, right? So because everyone has spoken about these 2 products, right, or these 2 open source projects. So I just wanted to touch upon this. Basically, KServe, you deploy a model in KServe. It can be a predictive or a generative model. Either of that can be deployed. It basically offers a scalable model deployment solution, right? So you can scale it down to 0, or you can just do an auto scale. The model's replica sets can keep increasing, and the model will be deployed, and additional replica sets will be created based on the parameters which you set in there. So it's a highly scalable auto-scaling model. It also supports canary deployments. And it supports various learning frameworks. For example, you can actually have different sorts of frameworks which are listed here as well on the right side. Second aspect, the product is VLLM for efficient LLM inference. So again, it's an open source library. It's maintained by VLLM community. It's a very thriving community. And it is used for deploying your models and consuming and reducing your overall resource consumptions, basically. That's the bottom line. So VLLM, you can use it as a runtime where it goes and gets deployed. The model gets deployed. And the main advantage is that your resources are optimally utilized. It helps speed up your Gen AI output, and it also helps do a GPU memory usage reduction, basically. These are some of the important aspects why VLLM actually is able to optimize the model serving or inference serving here. One is the page attention. So this is similar to the paging algorithms which used to work in operating systems, right? This is something similar where you have page attention. is used for memory management technique for the KV cache here, okay, from the model perspective, from the LLM perspective. Again, it uses speculative decoding. There are smaller models which are used to actually predict the next token, and the larger model to validate that prediction. There is flash attention. It's used for improving the performance of the transformer models. So, yeah. And this is an example of how we use VLLM deployment, right? On the left side, you see there is a VLLM serving runtime, and there is a model framework VLLM. So there are different types of VLLMs, as we will see in the demo. And on the right side, you see there are some specific parameters which you can use. Okay, so there are a lot of optimization parameters which are available from VLLM point of view, which you can actually add in there, and you can use it to have better inference or faster inference service with less resource consumptions for your requirements. Again, this is a demo link. Let me see the time check. So this is my model being deployed in KServe. If I see the details here, okay. This is how I see it as a serving runtime in my Kubernetes platform. For example, in OpenShift, so there are two important components which are created here. One is the serving runtime, and the other is the inference service. Okay, inference service is where you call the model. Service runtime is where that particular model gets deployed as a runtime. So this is my VLLM runtime here, and this is my inference. So if you see here in the inference, it actually calls the specific parameters in, like the arguments, the model arguments and all here. I think it's not very visible. It will come when I click this. And then you see there is this KServe which is being used here as part of the deployment of the model. Yeah, these are the parameters I was talking about as part of the arguments from the VLLM point of view. This is on the OpenShift AI, which is like, there is a project, open source project called Open Data Hub. Anyone heard of Open Data Hub? Right? Okay. So basically so we have actually used that product, okay, and we have productized it as well, right? It's called OpenShift AI. So this is the UI, the similar UI basically. And you see these are the models being deployed here. The one which I showed earlier, the serving runtime and the inference service in YAML formats, okay, these are the two deployments which is there on the UI part. Okay, the same thing which you see it in UI here. So this is the model, the Granite 3.2, the middle one. That's the model which I showed you earlier as part of the runtime and the inference service. And this is how you create this. If you want to create an inference service, you do a model deployment here. When you are deploying a model, you select the serving runtime, you select the model framework. In this case, we are doing VLLM, and you add whatever parameters or arguments you want to deploy the VLLM, right? And that's how you go and deploy the model, basically. This is the second model. Its parameters are detailed here. The one which I showed you, the same parameters are listed here as well on the UI. Right. And this is how you deploy the model if you want to deploy a new model. So these are the options available here, right? There are different options available depending on different types of GPUs or accelerators available. In this case, I have NVIDIA, so I'll select that. Okay, I'll select the model which I want to deploy with the arguments, and that will go and get deployed basically. Right. So that's how the KServe and the VLLM function together, and you see the runtime and the inferences being created here. Right. This is, I have also provided a link. You can actually go and join the community. If you want, you can go and join the Slack channel for VLLM. It's a very nice, thriving community. And there are meetups happening, regular meetups happening. So you go and check that as well, please. Okay, MLOps and best practices. I want to combine all these components together to actually create a very good MLOps experience, right, from the enterprise point of view. So that's the whole idea, right? For data scientists, you use Elyra, create your data science pipeline, and leave the rest to the deployment, CI/CD deployment, basically using Tekton, for example, as the pipeline creation for the deployment part, the model deployment part. So basically, we're trying to isolate the functions, the data scientist function and the administrative functions here, or the DevOps function. So this is where a new model, when it gets stored, right? A data science pipeline gets executed, a new model is stored in S3 pipeline, or in S3 bucket or a model registry, right? That will automatically trigger a pipeline in OpenShift or in Kubernetes, which will pull that model and actually deploy it in the runtime which we just discussed, right? In the VLLM or serving runtime, basically, as an inference service. So that this particular part, right, where the S3 connections are made, the inference service is updated, and the model is verified. This particular deployment part will be part of the CI/CD process, separate than the process which a data scientist uses in Elyra, right? So I'm trying to separate these two processes out, okay, by running this Tekton. So this is where the Tekton pipeline will run, right? So when there is a new model which gets pushed in, right? For example, in this case, I have this model.bin, which is getting pushed in. It's a new model being created. Okay, so this will go and update my event listener running on OpenShift Kubernetes environment. That will in turn create a trigger by running this trigger. This trigger will call this pipeline run, and this pipeline run will actually execute the 3 tasks which I showed you earlier, right? Where it will go download the model, okay, push it in the specific runtime configuration, and the model is available for inference service. So this is where these are the points where it actually creates the endpoints for those models being deployed. It can be a gRPC, or it can be a REST URL, either of that. Okay. gRPC works pretty fast compared to the REST URL. So just keep that a note. Right. And yeah, then models are deployed basically. And that's what I see it in my model deployment in the UI, in the OpenShift AI UI, okay, or in the Open Data Hub UI, that my model is deployed here. And I see the inference services as well, as listed here. Right. So that was about how the model gets deployed and as an isolated CI/CD process. So coming back to the circle here, basically, this is the same diagram again which I showed you, right, first time. Okay, we have data scientists going and connecting through Elyra, creating beautiful pipelines to actually right from the data processing to the model deployment and submission of the model in the model registry gets executed through a workflow pipeline, and data scientist doesn't have to worry about creating that specific workflow, right? They just drag and drop the Python codes, and the workflow gets created automatically. That's the beauty of Elyra. And then once the model is pushed in, oh, it's a new model, the Tekton pipeline triggers, right? And it will go download that model, push that model into the specific runtime which is being selected as part of a deployment process, and the model inference service is available with the new model being deployed. Of course, you can set a lot of things, like you can set monitoring at the Elyra when the Elyra data science pipeline is run. You can set monitoring when the Tekton pipeline is run. You can set security aspects as well when in whatever stage you are. And then you can have a monitoring on top of that, right? For you to figure out whether the models are being worked out, whether the model bias is happening or not, okay? Whether the model is optimally performing or not. So that is about the high level of this. Yeah, I just mentioned about some of the best practices separations here in terms of why you should have Elyra for the data scientist and separate out the concerns from the administration or deployment or scaling or runtime monitoring point of view to a DevOps ML engineer, basically. Okay. Right, time check. Cool. So yeah, key takeaways. This is, I think, the last slide. Elyra will accelerate your AI pipeline development and modernization. VLLM optimizes your large language model inference efficiently. MLOps ensures that your reliable and efficient models are deployed on your environment, and your KServe provides a scalable multi-framework model serving, right? So these are the key 4 takeaways for you from my session, basically. Right. Okay, thank you.